So actually, if you're using your PowerPoint slides, you don't have this slide. You might recognize this slide is clear back from Part 1, Unit 1. And this is like if you have matter, matter is made up of atoms that has mass occupied space. We can say that matter is a mixture, we can say matter is a pure substance. If it's a pure substance, you have two options. It can either be atoms of the same type of element, we would call that chunk of matter an element, or you can have atoms of different elements that are stuck together in a repeating unit that we're going to call a compound. So we're switching gears. We talked a lot about the elements. We're switching gears to compounds. Let's see if my pen works. One of the things I think is kind of fun, and I probably mentioned this before, is that you can take atoms and build them up into compounds using some sort of ordinary chemical reaction, and you can take a compound and break it down into its elements using some sort of chemical reaction. So I'll put it on the board. This is all I was going to do. Is if you have elements, and this is the unit that we get to talk about chemical reactions. You can use some sort of chemical reaction, CHM for chemical, RXN for reaction, some sort of chemical reaction to build up elements, to build up compounds. And you can take some sort of chemical reaction to break compounds back down into the elements. It happens all the time. So now here's a slide that you have. By definition then, a compound is a substance that actually has only one type of molecule or formula units. Now, I'm going to kind of talk about those two. What's the difference between those two words? They're both repeating units. A molecule is a repeating unit, a formula unit is a repeating unit of the compound. Okay. Now, if this kind of goes back up to here, this is actually what this is referring to. Sorry, this line down here. We can take a compound like water is a compound, sodium chloride is a compound, benzene is a compound, ethanol is a compound. We can break it down into its individual atoms of different elements using a chemical reaction. Ordinary means. And in order for it to be an official compound, you need to have some sort of chemical bond stuck between them. So we'll be talking about chemical bonds. So for instance, H2O would be an oxygen and two hydrogens. Okay, so as I've drawn them, this is the chemical bond connecting that single oxygen to those two hydrogens. Okay, it'll have a definite structure. So I'm going to show you a video here in a minute. I think we watched this video, but it is of the decomposition of mercury 2 oxide, and this is just still images of it. And I'm not sure what's going on with my this one right here.
Mercury 2 oxide breaks down.
So I was getting ready for lab. To me, this is the opposite of your magnesium oxide lab. Because in your magnesium oxide lab, we saw oxygen incorporated bond to your magnesium. And here we see oxygen atoms released from mercury 2 oxide. So I think that's kind of fun. Where'd you go? Yeah, I don't know why my little hot links aren't working. I'll have to figure it out. You know, this is sort of stuff that you've been exposed to before, I'm sure. So these are formulas. Like I said, I'm not a word person. Giving you a chemical formula or a chemical equation representing a reaction any day. Nice and concise. So, for instance, you guys are learning the names of some of these or making sure you got it on your belt. Ca is calcium, S is sulfur, O is oxygen. We'll be talking more about how you name them. Some of these coming up, but I just want you to know that this would be the repeating unit. So a little bit ago I mentioned this is either the representing what a molecule would look like or what a formula unit would look like, the repeating unit. And I'm going to kind of show you that there are two types of compounds right now. So what I like to do for this subject actually is go to the board and start kind of a list. Two types of compounds. What they have in common is we have two or more atoms of different elements that are stuck together with chemical bonds. But it's important that you're able to distinguish these two types of compounds. So compare and contrast. We have molecular compounds, and I put CPD for compounds, and then we have ionic compounds. CPD for compound. And then down the road, sometimes I'll definitely refer to this distinction and in other ways, how they're different. Molecular compounds, ionic compounds. Right off the bat, I can put a synonym for molecular compound is covalent compound. So, what else we got? Okay. So one of the things, the terms we've already run into was molecule and formula units. So for molecular compound, we call a repeating unit is a molecule. We use the word molecule. And in contrast to that, a repeating unit for an ionic compound is a formula unit. So the abbreviation for formula unit, no joke, is FU. And sometimes you'll actually see that on bottles. And you're like, really? FU is what? So formula units, repeating units. So kind of learning the vernacular a little bit. So as it turns out, and I'll tell you how you distinguish them, but all of these up here are molecules. All of these up here are molecular compounds. Yes, ma'am?
Whenever you say repeating unit, do you mean
Like if I go back to when I say repeating unit, I mean like you have one of those. That's the repeating unit. Like we're used to using formulas to represent a compound. So if you have one formula unit, for instance, as it turns out, these are listed in order. These top three are molecular compounds. These bottom three, as it turns out, are ionic compounds. So if I have one formula unit of, pick on ammonium sulfide, I'm hoping you guys know that, well, I'll ask this in the form of a question. If I have two formula units, how many nitrogen atoms do I have? If I have one formula unit, I have two. Yeah, if I have two formula units, I have four. Yeah, one formula unit, I have two. How about a one formula unit, how many hydrogens do I have? 8. How many people think 8? I do too. Yep. So this guy right here, that ammonium sulfide, looks like this. So we have a central sulfide ion, and it's actually connected to 2, thus the 2 outside the parentheses of NH4. So here's my NH4, and here's my other NH4. So when you guys told me 8 hydrogens, you're right. 2 nitrogens, you're right. How many sulfurs? 1. So to kind of get back to what I think maybe your question was, Olivia, when I talk about a formula unit, I mean I have one of these. I have one of these connections. And I'm going to show you in its solid state, if we were to look at ammonium sulfide, it's all kind of what we call connected. It's what we call a crystalline lattice structure. So these guys are all molecular compounds. And again, that'll make more sense here in a minute. So these will be molecules. So formula for methane is CH4. These are different representations of methane. We can go ahead and write out the stick model, kind of showing the relative positions of the carbon and the 4 hydrogens. This is kind of nice, and this is kind of nice. They all have their advantages for looking at a methane molecule. Methane is a molecular compound, so that repeating unit is a molecule. Benzene is a molecular compound, so that repeating unit is a molecule. Sometimes we call it the benzene ring. We have some structures out there that actually, their bonds kind of loop around. Those little black dashes are the chemical bonds, okay? So, benzene. Acetic acid, here in vinegar, Vinegar is about 8% acetic acid. So here's the structure of acetic acid. Here's another way to look at the structure of acetic acid. Again, these are molecular compounds, so they're showing you a picture of a molecule. Methylformate. This slide kind of says, and it's almost like if you're like, I was at my office and I'm like, wait a minute, those are the same atoms joined together, but just kind of in a different configuration. We call those actually isomers. There's different types of isomers. These are structural isomers. So they notice that they are both have 2 carbons, 4 hydrogens, 2 oxygens. I'm just kind of throwing this out there, some food for thought. Speaking of food, I probably would consume acetic acid. I'm not sure about methylformate. It's funny how they do different things biologically then. But those are the hardcore chemical bonds that are sticking those, 8 atoms together. You can see the oxygen here is different, is connected between the 2 carbons. And here, that kind of oxygen in the carbon chain is on the end with the hydrogen. So in all of those pictures, what we were looking at were molecules. I like to kind of go like this. Molecule, you can like sink your teeth into it. I'm like, dude, you're a molecule. You're not connected to anything else. Okay? So switching gears, what about ionic compounds? So I have a couple videos to show, all kind of forming that crystalline lattice structure. Yeah, you got it. Another look at an ionic compound, and now maybe you can kind of see why table salt actually, if it's just cleaved or crushed or whatever, it's going to make these nice straight edges. That's kind of fun. So what we've been seeing is kind of presented on this slide. If you look in the center of a crystalline lattice structure, for instance, like this slide says, for every Cl minus, we call it chloride ion, it will be connected to 6 other sodiums. So you're like, well, where's my formula unit? Well, I could take a pair anywhere in there. Okay. So anyway, formula unit. So now here finally we're going to add to our little compare and contrast here. Here finally is kind of the key to all of this. The other day we talked about that JAG. And I'll ask this in the form of a question. Do we have more metals or non-metals on the periodic table? How many people think? Yeah, we have more metals, exactly. Here's the JAG, we have more metals. In general, if your formula, and this works about 95% of the time, if the chemical formula for the compound you're trying to see what it is, if your chemical formula has a metal, it's an ionic compound. Okay? So over here, under ionic compounds, I'm going to say has metal. Has at least one metal. Has at least one metal. One metal atom. One metal atom in the formula. Okay? And then compare that to has no metals. Has no metals in the formula. Okay, that's it. And it works about 95% of the time. So what this is saying is, put another way, over here, you're going to have, if I use the word M to represent a metal and NM for a non-metal, you're going to have at least one of those, one bond between a metal and a non-metal. And over here, wow. We're just going to have NM, which is nonmetals, all bonded to other NMs, nonmetals. There's a lot of N's and M's there. All right. Now, so if we go back to this one. Oh, I have to add something to my thing. For purposes of looking at a formula and understanding whether it's a molecular compound or ionic compound, we're going to say hydrogen is considered a non-metal. So I'm going to add that here. Hydrogen, H, the letter hydrogen, is a non-metal. And actually this kind of gets back a little bit to why my black and white periodic tables and my periodic tables have hydrogen in 2 places. So a little bit. hydrogen nonmetal. I make that claim because, for instance, and don't feel bad if you have to look at a periodic table, water has hydrogen and oxygen in it, okay? Here's our J. Hydrogen is nonmetal. What's oxygen? Is it a metal or nonmetal? It's a nonmetal. So I said hydrogen nonmetal. Periodic table says oxygen nonmetal. It's a molecular compound. Where's carbon? It's a nonmetal too. Yep. So if you have carbon and oxygen compound, it's a molecular compound. Let's skip down to calcium sulfate. What's sulfur? Sulfur's a nonmetal. What's calcium? Calcium is it's a metal. Calcium's a metal. So find a metal. Why does it say, oh, has? It's like hydrogen, it says has. Yeah, so if you find a metal like calcium, it's an ionic compound. Now, the next one actually is one of the few exceptions. You would find nitrogen, metal or non-metal? Non-metal. Hydrogen non-metal, you told me sulfur non-metal. So you guys would tell me, according to what I said, that this is got all non-metals, so you're looking molecular compound. But as it turns out, this actually NH4, as I've drawn it up here for ammonium sulfide, that is what we call polyatomic ion. So it runs around with a +1 charge, which makes the sulfur in the middle actually is a negatively charged anion. It's a -2 and a 2 + 1. So actually that is an example of an ionic compound. So sorry. But what about the last one? Any metals there? Yes. Yes, which one? Magnesium. So ionic or molecular?
Wait, sorry.
Ionic. Ionic. So yep. If you ever get, and I'll put these up here. If you ever, I don't know if this helps, but a good example of ionic compound would be actually sodium chloride, NaCl. That's an ionic compound, and actually we looked at pictures of that. A good example of a covalent compound might be, well, H2O, covalent or molecular compound. Okay, that's as far as I wanted to get. So, go ahead and stop that.